Now we begin with the chapter number 8 of this first part. Okay, this is the last chapter of your this part 1. Okay, chapter number 8. Okay, in the beginning, the topics which are there, they are just not there in the course rather for this year. Okay, but still I am giving you an idea about that part. Okay, so that is not important for the point of view of your examination, but for the knowledge sake I am explaining it to you. Okay, now see, these are what suggestion was done to correct discrepancies in Ampere circuital law. Ampere circuital law was slightly inefficient to explain the different phenomena which was suggested. Okay, scientist Faraday suggested that time varying magnetic field produce electric current, that we know. This is Faraday's law. Maxwell suggested that electric field changing with time produces magnetic field. Try to understand this part. It's a very important statement which was given by this scientist, that whenever there is a change in electric field, okay, with respect to time, will produce the time that will produce the magnetic field. Okay, it is not electric field, it is magnetic field. Okay, Maxwell tried to obtain magnetic field in outside the capacitor when it is connected with the varying electric field. When the correct capacitor is connected with varying electric field, then he tried to obtain the magnetic field outside the capacitor. Okay, and Maxwell found there is a discrepancies in the law which was given by BDL mu 0 I. Okay, integration B dot dl is equal to mu 0 I, that is the law given by the Ampere circuital law. There is something which is missing, and Maxwell added this missing term as a displacement current. Okay, now this statement which is given by this scientist Maxwell, that is changing electric field produces magnetic field. Now see, Maxwell logically showed that by changing electric field, magnetic field can be obtained. Okay, this is a very important phenomena, and this phenomena first time was shown by Oersted, who was physics teacher, and this phenomenon explained radio waves, gamma waves, electromagnetic waves, and other forms of electromagnetic waves. So this is a very important phenomena, that changing electric field, or rather changing the electric field, we produce the magnetic field. Okay, so production of magnetic field by changing electric field can be explained, and changing charging of capacitor by using Ampere circuital law. So production of magnetic field by changing electric field. How to produce a magnetic field? By changing electric field, and that can be explained by charging the capacitor by using Ampere circuital law. Ampere circuital law is used to explain the charging of capacitor, and charging of capacitor is done with the help of the changing electric field. Okay, because whenever there is a charging process, gradually the charge is established. So during the charging process, the electric field vary, it changes with the capacitor, and that changing electric field will produce the magnetic field, and it can be explained with the help of this phenomena of charging of capacitor. Okay, now there is a derivation of equation of missing term in Ampere circuital law. Okay, write its definition and unit. Now try to understand, there is no need of derivation for this year. We just have to remember the equation which was derived. So that equation which was derived, as you know, that Ampere's circuital law is nothing but, it is nothing but integration B dot dl, B dot dl, and that B dot dl is equal to mu 0 I. Now that current is divided into two parts. One is the current due to the conduction, or we can say IC is obtained due to the flow of charge, so it is a conduction current. So that current is divided into two parts, that is IC, and one is the displacement current which was introduced by Maxwell. So IC plus ID, it is divided into two parts, IC and ID. So the equation of the Ampere's circuital law can be here, it can be B dot dl, integration B dot dl is equal to mu 0 IC plus mu 0 ID, and if you take mu 0 as common, then it can be IC plus ID. Try to understand the total equation which was given. That equation as such by the Ampere was B dot dl, it was mu 0 into I, but this I is divided into two parts, that is IC plus ID, that is I at any time t is IC plus ID. Now see, this term was introduced by the scientist Maxwell, and no need of derivation for the sake of for this year only. We just have to just remember the final equation. That final equation can be written as, see, its left hand side is as it is, its conduction current is as it is, mu 0 IC. The final part, this, that is nothing but mu 0 ID, that is displacement current. Okay, that ID, that is displacement current, is written by epsilon 0 d phi E by dt. It is d phi E by dt. So here just you can understand this, that this part which was there, that is integration B dot dl is equal to mu 0 IC plus mu 0 ID. Instead of this ID, we have epsilon 0 d phi E by dt. So our equation will become this, just you have to remember. Okay, that is integration B dot dl is equal to mu 0 IC, that is the conduction current first part, that is okay. The extra term which is added is mu 0 into ID, and ID is epsilon 0 d phi E by dt. So this part is nothing but the displacement current term, that is this. Okay. So this equation was derived by Maxwell. Okay, and discrepancies were removed or adjusted. Now these are the effects of displacement current. By using displacement current law of electric field and magnetic field can be represented symmetrically, but again they do not represent total symmetry. This is due to reason that source which produce electric field are charge which can be single, but source which produces magnetic field are not magnetic monopole. Okay. Also Faraday's law of electromagnetic induction shows that induced EMF is equal to time rate of change of magnetic flux. This can be written like this: magnetic field changing with time produces electric field. Symmetric statement will be electric field changing with time produces magnetic field. Displacement current is source to produce magnetic field. Thus electric and magnetic field changing with time produce each other. Try to understand. If magnetic field produce with time, then that produces electric field, and electric field changes with time produces magnetic field. So electric and magnetic field changing with time produce each other. Faraday's law of electromagnetic induction and Ampere's Maxwell law gives quantitative representation of these things. Okay, most important outcome of symmetry is electromagnetic wave. Now see, these are Maxwell's equation. They are a combination of Gauss law of electric field that we have studied in the first chapter. Integration E dot dA is equal to Q upon epsilon 0. Gauss law for magnetic field is integration B dot dA is equal to 0. Faraday's law is nothing but integration E dot dl, that is equal to minus d phi by dt. Rate of change of magnetic flux gives you induced electromotive force. Okay, and that induced electromotive force is nothing but contour integration or closed integration E dot dl. And then Ampere's Maxwell law is V dot dl is equal to mu 0 IC plus mu 0 epsilon 0 d phi E by dt. Okay, here all these terms are having their what you call it, original meanings that we know. Here d phi E by dt and d phi B by dt. Okay, d phi B by dt is rate of change of magnetic flux. This is rate of change of electric flux. IC is conduction current. ID is displacement current. Mu 0, as you know, permeability of vacuum. Okay. Now this is just again only for the information how electromagnetic waves are produced. See, stationary charges or charges moving with constant velocity cannot be source of electromagnetic waves. This is due to reason that stationary charge produce electric field and moving charges produce electric field and magnetic field, and these fields do not change with time. Field must change with time. So if they are moving with constant velocity, then the field will not change with time. According to Maxwell, accelerated charges produce electromagnetic waves. Okay, so oscillating charge is an example of accelerated motion. Okay, when charge is oscillating with some frequency, it produces electric and magnetic field oscillating in the space. When this phenomena is repeated, electric and magnetic field propagates in the space, which are called electromagnetic waves. Okay, frequency of electromagnetic waves is equal to frequency of the oscillation of the charge. Energy of accelerated charge is imparted to electromagnetic wave propagation. So whatever is the energy of accelerated charge is given to the electromagnetic wave propagation. Now it is easy to imagine that light is electromagnetic waves, but difficult to test in the laboratory, because by using modern electronic circuit, frequency of 10 raised to 11 Hz can be obtained by frequency of yellow light obtained in the visible is 6 into 10 raised to 14 Hz. Try to understand, 6 into 10 raised to 11 Hz is the frequency which can be obtained in the laboratory, and the frequency of yellow light is 6 into 10 raised to 14 Hz. Hence, to give experimental proof of electromagnetic waves, Hertz experiment should be performed in lower range of radio waves. After success of Hertz experiment, Jagdish Chandra Bose, working at Kolkata, succeeded in producing and observing electromagnetic waves of much shorter wavelength, that is up to 5 mm to 25 mm. His experiment was confined to the laboratory. During this time, Italian scientist Marconi was succeeded in sending electromagnetic waves to several miles. Okay. Now this is an important topic. Write the characteristics of electromagnetic waves. Now see, in electromagnetic waves, electric field and magnetic field are perpendicular to each other. So this is first characteristic. This is your first characteristic. Both the fields are perpendicular. There is electric field and magnetic field. If you show it, the electric field this way, okay, it is propagating, or rather say oscillating in x direction, then the magnetic field is perpendicular to it, which is oscillating in this y direction. So both are perpendicular to each other, and the propagation of this electromagnetic wave is in z direction. Okay, so during charging process of capacitor, electric field inside the plate is perpendicular to the plate and magnetic field produced due to displacement current is circular and parallel to closed loop and in direction of plate, hence E and B are perpendicular to each other. If you consider the charging of capacitor just for the sake of understanding, electric field is in this direction, then the magnetic field is perpendicular, that is parallel to the plate, we can say. So both electric field and magnetic field are perpendicular to each other. Okay, second property, let plane electromagnetic wave propagate in z direction. See, this I have tried to explain that the waves are propagating in z direction. Then electric field is oscillating in x direction and magnetic field is oscillating in y direction, and their equations can be written as Ex, that is electric field is in x direction, is equal to E0 sine kz minus omega t, as we have seen this, that x is equal to okay a sine, we have written this, okay, kx minus omega t. This is our wave equation we have studied in the 11th standard. So this say wave equation is written, that is x is equal to a sine kx minus omega t. This way the displacement of electric field vector, okay, that is given by Ex is equal to E0 sine kz, because it is moving in z direction. So it is z. If it is moving in propagating, okay, because try to understand, the oscillation of electric field vector is in which direction? Oscillation of electric field vector is in x direction, so it is Ex. And propagation is in which direction? It is in z direction. Okay, so Ex is equal to its maximum value of displacement, that is amplitude E0 sine, okay, then the direction of propagation, that is kz, z is the direction of propagation, minus omega t. Now similar equation you can write for magnetic field. Magnetic field is oscillating in y direction, so this will be By is equal to B0 sine kz minus omega t. Okay, here y component of electric field and z component of electric field is 0. Okay, it has only x component, therefore we can write in the vector form E is equal to E0 sine kz minus omega t I cap. Similarly, B is having only, magnetic field is having only y component, so it can be B0 sine kx minus omega t j cap. Now as you know, k is 2 pi upon lambda, which is wave vector, and omega is angular frequency, and as you know that omega upon k is wave speed. This we have studied in our 11th standard. So omega is equal to wave speed, that electromagnetic waves are having the speed that is denoted by c. So omega is equal to c into k it becomes, okay, where c is 1 upon mu 0 epsilon 0, okay, c that is speed of light, as you know 3 into 10 raised to 8 meter per second, which is 1 upon under root of permeability of vacuum and permittivity of vacuum mu 0 epsilon 0. Okay, as omega is equal to ck is standard equation for the wave. Omega is 2 pi nu, okay, c and k is 2 pi upon lambda. So we can write here easily 2 pi can be cancelled out. Okay, so nu, that is frequency, is equal to c upon lambda, or speed of light is nu into lambda. Okay, this also we have derived, v is equal to nu lambda in the 11th standard. Okay, now these are very basic and important things that we have already studied, rather some of the things in 11th standard. Now see this property, that is magnitude of electric field upon magnitude of electric field upon magnetic field. Maximum value E0 upon B0 is equal to C. So B0 is equal to E0 upon C. Okay. In free space, now fourth property, in free space, oscillation of electric field and magnetic field are self-sustained. Thus, for oscillation of electric and magnetic field, medium is not required. Without medium, electromagnetic waves can propagate. Sound waves require medium, but here this electromagnetic waves, which are transverse waves, as you know, they do not require the medium. Examples are there: sound waves in air, sound waves in solid medium, transverse waves produced on water, they all require medium. Okay, while these waves do not require medium electromagnetic waves. See, electromagnetic waves are transverse and non-mechanical waves, they do not require medium. Okay, they are transverse waves. Their speed of light, okay, electromagnetic waves are having the same speed, 3 into 10 raised to 8 meter per second. Okay. Scientist Hertz showed that electromagnetic waves experiences diffraction, refraction and polarization. All these properties you must remember. In 2 marks you have to write 4 simple properties whatever you are knowing out of all these 10 properties. Okay. Any 4 properties you just have to remember properly, you can write. Okay. And this is having 4 marks weightage. This chapter is having only 4 marks. So 2 marks will go in MCQ. So there will be a question of 2 marks, small numerical, or we can say these properties which we are discussing right now. Okay. Now electromagnetic waves transmit energy and momentum. Okay, as you know, electric field vector is there, a magnetic field vector is there, and energy density of electric field and magnetic field we know it is 1 by 2 epsilon 0. This is epsilon 0. Okay, epsilon 0 E square, and the other one is 1 by 2 V square upon mu 0. So total energy density will be the sum of these two. Okay, 1 by 2 epsilon 0 E square plus 1 by 2 B square upon mu 0. Okay, now as you know, E upon B is equal to C, so instead of B we have written E upon C, and as you know, C is equal to 1 upon mu 0 epsilon 0 with square root. So here instead of this B, okay, we are writing E upon C. Okay, just close look at it. Okay, we can write, replace and simplify. Okay, instead of B we write E upon C. Okay, so here it is written as E upon C, so it becomes E square upon C square, and that C square will be 1 upon mu 0 epsilon 0, so it is replaced by 1 upon mu 0 epsilon 0. So here mu 0 will be cancelled out, so you will have 1 by 2 epsilon 0 E square, first term as it is, this goes in the numerator. Okay, so it again becomes 1 by 2 epsilon 0 E square, so half and half will become 1, so rho is equal to epsilon 0 E square, which is equation of electromagnetic energy density. Now 10th, when electromagnetic waves collide on a surface, it exerts pressure on the surface, which is called the radiation pressure. Energy incident on any surface in time t is U, and this energy is completely absorbed. Then momentum imparted will be P is equal to U upon C. All these things are the properties you just remember. Okay, so momentum imparted when energy U is incident, that is P is equal to U upon C. Okay. 11th property, electromagnetic waves carry energy, hence from transmitting station it can carry radio and television signals. These electromagnetic waves carry energy from the sun to earth, hence life sustained on the earth. In region far from source, oscillation of electric and magnetic field are in same phase. Okay, if the source is there and if you are at very large distance from the source, then the phase difference is not there between the electric and magnetic field, or we can say they are in phase. And the direction of this propagation is nothing but E cross B. Okay, that is giving you the direction of propagation of electromagnetic waves. Okay, so try to understand these properties, prepare them properly. Okay, there may be definitely a 2 mark question for this property, or other question can be asked as a short question which are there in the last further topics. Okay, thank you very much.